This is the world of terms. And so you have lots of terms, actually. And in this world, you have a kind of area where you have only terms about movies. Okay? Like theater, actor, horizon form, whatever. So I know that in this world of terms, I can find some terms which are relevant to the movie world. Let's have a look in the actor criteria. So in the actor criteria, as you can see here, I will have some terms which are related to actor, okay? And this is the kind of terms that I'm interested in. So this is my C terms, for instance, actor, acting, and characters. And what I would like to do is to learn these terms, and these terms. So what are the initial level of interpretation? This is interpretation, one of my C words, and then I can try to find some terms which are very close to neighborhood. For instance, I can learn actors, film, which are relevant for the actor criteria. Okay? And then, by performing such a process, I can find also theater. What's about theater? Is theater relevant for the actor criteria or not? When you talk about actor, do you talk about theater? Or theater is much more relevant for the movie done? Actually, theater is much more relevant to the movie done. This is why we introduced two different classes. The first class, actually, corresponds to the specific term for criterion. Okay, so that means that this is a class, and in this class I will find the interpretation, actors, and films, and the anti-class is the generic sense of the domain. So all the words that are embedded in the movie domain, but which are not included in a specific criteria. So, how to build the training corpus? As I told you before, I would like to avoid that the end user will be involved a lot in the process, because it's very time consuming. I can't ask everybody to take a document and say, this is relevant to my criteria, this is irrelevant to my criteria. It's too time consuming. So my idea is, we have a huge information available on the web, and then let's use it. So, okay. It could be Bing, it could be Yahoo, whatever the search engine. And then this is an example of a query that we could ask to Google, for instance. So the system actor, I will query for, plus means that I need that movie occurs in the document, and when you have a minute, it means that I do not want to have this word adaptation in the document. So I will ask for documents in the domain maybe, having the criteria of the seed word actor, and removing all the words which are in the scenario criteria. And in the same way, I will do that for the anti-class. And for the anti-class, I will specify the domain, okay, I'm working on the movie, and then I will remove all the seed words coming from the scenario or coming from the actual criteria. So at the end, I will be provided 300 documents per movie in the anti-class, and for different seed words, I will get 300 documents. And this is for the actual criteria. I perform the same for the similar criteria. So let's go to the learning step. We consider this hypothesis: the more word is correlated with the seed word, the more likely it expresses the same concept. So the idea is, when I have a seed word, I will have a look on the words which are very close to the seed word, and probably they are talking about the same concept. We consider that common names are very useful. For instance, the name of an actor can be very useful. A recent form must be in the class of actor. So what we do, After the processing of the document, we focus on the seed word, and we have a window centered in this seed word, return icon, and then I can compute the distance between different words, common words. And then I will try to get a measure according to the distance. That's quite simple. Actually, it's a little bit much more complicated. Because, for sure, you have to take into account the distance between common names, but you also have to consider other terms that can occur in the sentence. For instance, you can have verbs, you can have adjectives, adverbs, and so on. And it means that all these words will do that the common names can be far away from other common names, so the distance is not enough. And then it means that we need to take into account a kind of Gaussian measure in order to take into account the number of terms. This is the number of different kind of terms. What are the terms? Separating different common names. And by combining all this distance and all the common terms, you are able to find a kind of term frequency. It's not really a term frequency, it's not so far from a term frequency. So, let's have a look at the first question. This is what we get. So this is the class, this is the anti-class, and as you can see, film has a very high score. So it probably occurs mainly in the actor class. Theater. So the previous term that was boring for us. So, as we can see here, theater occurs on ons. So it's typically not relevant for the actor preacher. And as you can see, it is in the anti-class, 370. But it means that it's much more relevant for the anti-class, so I mean for the domain movie, than for the class. Let's have a look at actors. As we have seen before, class is relevant for the criteria actor. And then, term frequency, yes, it's very high for the class, and not very high for the anti-class. So it's completely relevant for the class. Oops. Not fun. Two. What does it mean? It means that I'm not able to say that if this other actor occurs in the class or is anti-class. So what do we do? Actually, we will consider terms having the same kind of value between class and anti-class, and we consider these terms as candidate words. What does it mean to have a candidate word? Why do we have candidate word? Probably because the learning corpus is not quite complete. We have only downloaded some 300 documents from the web, and maybe in these documents you do not have any information to get the relevant value from this chart. So what do we do? We only have to find some documents containing candidate words, and we can apply exactly the same process. We can request web, movie. This is the domain we are working on, casting, and we have the candidate words that we are interested in. It means that we force to find documents having all the candidate words. And then we are provided with many documents having this information. And then we have enough information to get relevant records. And then easily we can compute the new frequencies. Frequencies are nice, but maybe they are not enough. And then what we really need is a scoring function. The idea of the scoring function is that we really would like to say that this is in the class and this is in the anti-class. We can find many different scoring functions. We have taken this one. Typically the idea is when I'm in the class, I will be far away from the anti-class, And when I'm in anti-class, I will be far away from the class. This is why we have 3 here and 2 here. But you can choose many different kinds of scoring function. And this is the result, as a discrimination of the result. As you can see here, we have the name of the actor. And as you can see, the score is very high. It means that there are actors, and when we talk about these actors, they are relevant for the criteria. It's important to have these actors automatically extracted. Actors has a very high score. And as you can see here, it's typically in the anti-class. And then, by taking all this calculation, we are able to create a vocabulary, a dictionary or a lexicon. And then we are happy, because we are able to discriminate different kind of classes and information in the anti-class. In the anti-class, we have the description of the domains, and in the class, we have the description of all the criteria. So let's use this criteria, this vocabulary, to segment the document. What do we do usually? In opinion, we get all the terms from the opinion, we use some sliding windows, and we compute the score. And we find that this part of this sentence is about this criteria of this opinion. Okay? And for instance here, this is a sliding window, and the score is very low. It means that it is not very relevant for this criteria. I can do the same. Oh, the score is very high, so it means that this part of the sentence is very relevant for the document. And that it is probably talking a lot about criteria actor. And we can have several segmentation because we have sliding window, and we can get a kind of average scoring function. And if you have a sliding window, considering all the whole terms, maybe you can have a score 0. Because your document will talk a lot about the domain, you have a lot of information about movies, and you have some sentences about the criteria. So this could be probably 0. So it's completely irrelevant. But by using this kind of approach, we can have an average of the trend about some criteria. Well, another the idea is how to determine semantic breaks. More precisely, we would like to take into account the user experience. When you are reading a review, when you are an expert, you say that, okay, by only taking into account 2 words, I know that this part is about to protect this criterion. I don't need to have all the vocabulary for this criterion. And this is what we would like to extract. So basically, the idea is to find a kind of threshold from which the windows has a score. This is the size of the windows, greater than this threshold. And the main idea is to evaluate the sensitivity. More precisely, we would like to study the behavior of the system over its entire range. What does it mean exactly? It means that you will be provided by such kind of information. This is the threshold, and by varying the value of the threshold, what you could get? You could get that in the document, the value between 5 to 24, you use 100 terms corresponding to the criterion. It means that in this segment, I have all the terms that I have run before. While here, as you can see, you need only less than 60%. And here, you need only less than 40% of words. So the main idea is that depending on the user, you can have different kind of sensitivity. And so, by using this kind of information, you are able to provide this kind of tools. Depending on my sensitivity, I can select what I'm interested in. If I'm interested by a broad idea of the criteria, then I can say that, okay, I need only some words relevant to this criteria. I do not need to have all the words. And then, as you can see, you can have different kind of segmentation. Here I have 2 sentences, while here I have only 1 sentence. So, let's have a look on the evaluation. So we have evaluated this with a movie, restaurants, with 2 different criteria. And this is the size of the vocabulary that we have extracted for the class and for the anti-class. Between parentheses, this is without candidate generation. We do not take into account candidate codes. That means this is the first step. And here, this is value by using candidate evaluation. And as you can see, the F measure is quite high. Just for comparison, we have compared this with the 99 texting, which are used for segmenting documents, and as you can see, the score of our approach are very high. So, let's have a look at how to extract opinion and present. We can use the same, exactly the same principle. So I is okay, I will have to specify generic opinion terms, so seed words. So for positive, I can find good, nice, excellent, positive, fortunate. Okay, it's very easy. And as why usually we consider positive and negative, here we consider 4 classes. Positive, non-positive, negative, and non-negative. Basically, non-positive and non-negative are more or less similar to the anti-class that we have seen before. Because you can be non-positive does not mean that you are negative. So this is the language. What do we take also into account? We take into account adjective because usually they express, they are very useful to express opinions. We also use the word verbs. And we also define some explicit patterns like adverbs plus adjectives. Here's the idea is, I would like to automatically learn the way you express negative expressions, which are usually expressed by combining adverbs plus adjectives. And as we also would like to take the specificity of the domain, we would like to avoid to find this kind of sentence. Never you will see this movie is comfortable. You can say that your share are comfortable, but we do not take about comfortable for the movie. So the same process, I query the web, I will have some positive documents, negative documents, I will try to learn generic opinion terms, and I will generate a vocabulary, positive and negative, and then after, I have a text, I extract the opinion of this text, and I can give the score. So we use the same idea. We have a sliding window. Here you have the class, this is the seed word, and then by moving the sliding window, we try to find all the verbs, all the adjectives, and all the adverbs that are very close to this seed word. And this is the result that we can get. For instance, on good, as you can see, is very positive, for sure. Very nice. As you can see, this is an adverb and an adjective is also very positive. It means that I'm about to say that very nice, I can give a score, a value for very nice. And this is important. Very often, what do you do when you are very? It means that now I am nice, okay, nice has a score. What does it mean very nice? It's better. But what is the range of this value? And with this approach, we can automatically learn this value. In the same way, not important. I know what is important. Important is positive, not important is negative, but in which range can you set not important? And this is not very easy. And with this approach, we are able to automatically detect this one. And in the same way, we can generate also candidates when the value of the frequency is very low, and then we can also apply the same approach. We also define the same kind of score discrimination function, and as you can see, this is, yes, so very nice as a very high score, good as a score, a good score. Not really as good. Not really as good. Is it positive or negative? Actually, here we have learned that it's positive, but with a low value. Not ugly. What is the value of not ugly? Usually when you have to take into account other, you say that if I have neither nor not, then you say that, okay, I can say that the value is, let's say, 30% less. This is an heuristic, okay? With this approach, you are able to automatically learn the value according to the criteria and according also to the domain. Because in different domains, you will not express your opinion in the same way. And one for sure is with a high value. What can we do with this opinion? The most simple way to deal with it is to get your opinion on the text. What do I have to do? I only have to use a sliding window centered on the text, which are in the lexicon, positive or negative. I can compute the score for each document, and then I can aggregate the score for the document. And then I will know if this document is positive or negative. It's very easy to classify a document as positive or negative. What's your criteria? Actually, the idea is we have to combine segmentation, the previous one, as well as opinion extraction, the one I have just presented. By the segmentation, we have a kind of further score. Because we have an interval of values, as I told you, we would like to propose the end users with different ways of segmenting his documents. And then, for example, for documents, I will have a range value between 9 and 11. Okay. So some evaluation. This is for the evaluation test. I would like to know if this document is positive or negative. Okay? We have compared the result with scientific data. It's not the best, but not so bad. And with the proposal. And as you can see, we have very high score for the air pressure concentrates 0.69. While in the negative, in Sentinel, we have 0.37. Actually, it's much more difficult to extract the negative opinion. When you like something, you say, I like it very much. When you do not like something, very often you do not express this as you do for the positive aspect. So this is why negative aspects are usually much more difficult to get. And in the same way, for the evaluation of opinion of criteria, as you can see, we have a very nice positive result. For negative and negative, we are able to get very high values for the opinion which are expressed over criteria. So, I have 5 minutes. I would like to show you some different guesses. What can we do with this kind of tools? First of all, I would like to show you that these algorithms can be used for a recommending system. So this is the traditional recommender systems. Okay, I can already use. I can apply text mining, opinion mining techniques. I can apply fuzzy or not fuzzy evaluation of documents. I can perform some version of evaluations. And usually you have to take into account some multi-criteria aggregation. I give much more score for this value or not, depending on the criteria that you select. And then I can recommend on some result or some movie. But what happens when the movie is not in your database? For instance, a new movie is just arriving, and then you know that this movie is we have seen Star Wars producing. In December, what are the opinion of the people about Star Wars? My problem is, on which newspapers I will have the opinions that are interesting about. And it is a matter. So the idea is, I would like only to extract the strategy of newspapers and how they define the different criteria on the newspaper. So you can change a little bit the process, and actually this is the same process, and you have qualitative evaluation by experts, and then you try to detect the strategy of the newspapers. And then you can recommend to read the newspapers according to the criteria that you are interested in. And this is the result that you can get. So they are the French newspapers. And as you can see, if you are interested in the scenario, then maybe you have to read only this newspaper, because it will only talk about scenario. If you are interested about scenario or actors, maybe you have to read only this newspaper, because it talks about, and in the same way, on criteria and on actors. Another example. Who is this guy? Do you know this guy? Yeah, you know this guy. So actually, the system is Strauss-Kahn. So this is a French economist, lawyer, politician, and member of the French Socialist Party. Maybe you do not know this guy because he has held this part. You probably know this guy because of this story. So actually, Denis Strauss-Kahn, BSK, he was the head of the International Monetary Fund, and he has been in charge of sexual assault against Nafisa Diallo. Do you remember the story? So what we have done is only to evaluate some criteria over newspapers. So the data are used from the New York Times. Fortunately, information are located, and we were focused on two different criteria: IMF, which is for the economic part, and sexual assault. This is just an illustration, no any political opinion what I will choose. And then this is what we get. For every month, we can have some opinions. I will show more important parts of the society. First of all, in May, so this is a sexual assault accusation by Nafisa Diallo. And as you can see, in US, there is no real reaction, except in France. Okay. I have to tell you that the SK has already a long story in France about some sexual issues. Okay, so only in France you have a bad opinion about that. In June, the SK has been considered as victim. So the main consequences is that even in IMF, for sex criteria, okay, we can understand that, even in IMF criteria, you have very bad opinion about the SK in all the newspapers. In August, the SK has been considered as not guilty. Okay? For IMF criteria, the opinion remains the same, and as you can see, it was fine, but in Italy, they talk a lot about DSK because they compare him to Berlusconi. Berlusconi is the president of the council in Italy, and he was also involved in sexual assault, prostitution, and compared a lot with DSK. April to 2012, it was the French presidential election, and as the criteria, IMF and sex criteria are very important. We had a very negative opinion in France on both criteria, while otherwise, we do not talk about DSK anymore. In May, Nafisa Diallo has made a complaint, and here also, as you can see, it was not relevant to sex criteria, but to IMF criteria. It means that there are many consequences also on economic parts. So, to conclude, I show you the thematic approach for opinion mining. This is quite simple because it's multi-domain and you can define many different criteria. And the main advantage is that it's not so supervised. I mean that all the resources can be automatically learned. What you have to create a domain, a set of criteria, and some SQL. And then after the process can automatically learn names, for instance. Names of actors is not very easy to learn. And negative expressions as I told you before, it's very difficult to deal with negative expression. So it is easy to employ and could be useful for different applications. So thank you very much for your attention. So as you can see, Montpellier is not far from Cusco, and you're welcome to Montpellier. You have very nice beaches, nice places, and if you have
a nice mixture between theory and practical applications. So we have a microphone that circulates. If you have questions, please feel free. Any questions?
How will you handle the mistyping post? You know, maybe the mistyping post, because we are talking about Natjaimon, and I type wrong Natjaimon, so I'm tracking about this guy. So how do you add to the corpus, maybe, this error, or how you can handle it?
Actually, this is done by using the search engine, because I write this at the right name. So usually when you get the documents, you have the right name. But what you can do sometimes in that kind of approach, if you do not have any documents, then you can apply some Levenstein distance in order to find if they correspond to the same name. But as we are using search engine, so we provide the right names usually. And I do not talk about that, but I said that we need to talk about 300 documents, but basically with only 200 documents, you get the right answers. And in 200 documents, usually you have the right names.
By the way, if you don't dare asking the question in English, but you have a question, you want to express it in Spanish, feel free, because we have translators. Or in French too, we have translators.
My question is kind of related. You said about actors and actors. Have you considered about the use of stemming on these words? Because for the actor criteria, it kind of seems the same for me, that actor and active would mean the same.
What do you mean they would be the same?
I mean, for the semantic meaning?
Yeah, the semantic meaning is the same. But in my text, I will have some parts talking about actress, and I will have some parts talking about actress. This is why they are relevant for the paper. This is why very often you will have the female malformation.
It's kind of like forced to be free.
Yeah.
So I'll take the liberty to ask a question myself. In the approach you showed us, as well as the applications, the criteria are given. So they're given. Sometimes we'd like to discover them. Is there a way to discover them? So I give you an example. I was traveling, and I was looking for hotels, and typically the way I do it, I look at the reviews, the most recent reviews. And there was a hotel that people said positive things about it, but there's one very negative review. And when I read it, it was negative because they said they have kids and the kids are very noisy. But I was traveling with kids, so actually that didn't matter to me. But this person put a very negative review with no stars whatsoever. So it seems that the criteria now children wasn't part of the review. But for me, I'm interested in children. So how can I distinguish between the reviews that mention kids, that criteria, and those that don't? So I'd like to discover some of these criteria that initially were not set.
Yeah. That's a very good question. I think that maybe one solution could be to use some segmentation tools in order to get some parts of the documents. and then to focus on these segments in order to find if they are relevant to some criteria or not. This is what we have done with the text filling when we were 99. And then, when they are not relevant to the criteria that you are focusing on, then you can try to. But you need the expert. You probably need the expert to say, are you interested in this kind of segment and in this kind of criteria, and how to define this kind of criteria? Because then after you can say that, okay, if I have tried, I need to select some words, some seed words, it could be noisy, it could be that would be very nice or whatever.
Thank you for the interesting talk. I'm just curious, I think your approach is applicable to any language, including Spanish or other language. What would be required though to adapt to a new language?
Seed words.
A part of speech tagger maybe?
I think seed words are...
So you are not using even a part of speech tagger to get actors and nouns and very good adjectives?
But basically we use seed words and then after part of speech
so then at least a part of speech tagger for that language?
You can use Spanish or whatever.
Okay, thank you.
Any other questions? Question there?
Our increase the size of the slide. Yeah. Actually, we have performed some experimentation by using association rules. Yeah, association rules in order to find the most relevant, you know, the data mining rules for association rules. So the idea is to get rules visualized support, and we have found that usually the size of the window is small. It's quite small, it's more or less two terms before and 2 terms after. Because, and then we have applied some classification and evaluate the estimation. And by using 2 terms, this is usually the best way to